Okay, let's talk about a project that's trying to completely rewire how we think about energy. It's a story about taking our most fragile, critical infrastructure and turning it into a source of profit, not just a problem to be solved.
And it all starts with this one kind of wild question. We all think of grid failures and blackouts as these huge liabilities, right? They're risks we have to manage. But what if that very instability, that weakness, could be flipped on its head and turned into a massive strategic asset?
So, to understand how that's even possible, we first need to look at the big idea from the company behind all this, Reticular. It's a concept they call the sovereign stack. At its core, the mission is to build infrastructure that's so self-reliant it can literally just unplug from the rest of the world. They call this island mode, and it means total independence from those national grids and supply chains that, as we've all seen, can be pretty darn unreliable. This whole stack has three key layers. First, you've got the muscle, which is all about generating power, a lot of times from local waste. Then there's the motion. That's autonomous robots and vehicles handling all the logistics. And finally, tying it all together is the mind, a really sophisticated AI that acts as the brains of the whole operation.
So that's the big idea, but how does it actually work in the real world? Well, it's being put to the test right now through a global network called Project Octagon.
Project Octagon is made up of 8 interconnected sites, or nodes, scattered around the globe, and each one has a very specific job. You've got nodes in Uganda focused on industrial power, Canada is home to the software brain, and Arizona is there to stress test all the hardware in that crazy desert heat. Each one is like a different piece of a much, much bigger puzzle.
Now, here's what makes this network so powerful. These nodes are not working alone. They use a system called federated learning. So what does that mean? It means a lesson about, say, battery performance in the Arizona desert is instantly shared across the entire network. The node in Canada learns it. The node in Uganda learns it. It's a kind of collective intelligence where every part of the system gets smarter in real time.
For the rest of this explainer, we're going to zoom in on one really special part of this network, Node 5. Its nickname, the Energy Student.
So Node 5 actually represents this huge strategic pivot. See, it didn't start in Texas. It was originally way up in Minnesota, testing all the equipment in freezing tundra mode conditions. But it was relocated to Texas to take on a completely new challenge, to master the wild art of energy trading.
So why the big move? Let's dig into why this relocation to Texas was so absolutely critical. It's right here, in the heart of America's most chaotic energy market, that Node 5 really began its education.
Texas was chosen for 3 really smart reasons. First, its power grid, which is called ERCOT, is basically its own island, totally disconnected from the rest of the country. This makes it notoriously unstable, the perfect real-world lab for testing that island mode tech. Second, the market is deregulated, which opens the door for real-time energy trading. And third, it acts as a digital twin to the industrial node in Uganda, which generates amazing data for insurers about how the exact same equipment performs in 2 radically different climates.
And if you want to understand the financial stakes here, you just have to look at this number, $5,000 per megawatt hour. During a crisis, like a massive heat wave or deep freeze, that's the legal price cap on the Texas grid. That kind of insane volatility creates an unbelievable opportunity, but only if you can sell your power at the perfect moment.
So how do you make that split-second decision? Well, you don't. You let an AI do it. This is the trader. It's the brains of Node 5. It is constantly crunching market data, weather forecasts, and grid conditions to decide all on its own whether to buy cheap power and store it, sell that stored power back to the grid for a huge profit, or just disconnect entirely and run on its own.
And this whole strategy creates 3 totally separate ways to make money. The biggest returns, they come from that high-stakes energy trading or arbitrage, but it also generates a nice, stable income by selling what are called ancillary services, basically using its batteries to help stabilize the grid from second to second. And finally, it gets a little niche income by selling its unique performance data. It's a structured business model built directly on top of chaos.
So what's the bigger lesson here? I mean, why does mastering the Texas grid matter to the rest of the world? This is where Node 5's role as the energy student really, really shines.
Think of Node 5 as the network's university. The incredibly complex trading algorithms it perfects in the Texas pressure cooker aren't just for Texas. They get packaged up and exported to the other nodes, like that huge industrial park back in Uganda. All that intelligence helps the Ugandan node manage its own power way more effectively, maximizing its profits by knowing the absolute best times to use its own energy or maybe sell some back to its local grid.
And this, right here, this is the core idea. By intentionally putting a node inside one of the world's most fragile grids, the project proves that resilience doesn't just have to be a cost, something you pay for to defend yourself. It can actually be a financial weapon. It literally transforms grid fragility from a risk you have to manage into a revenue stream you can actively tap into.
And that leaves us with a final, really provocative thought. This whole project reframes a massive problem as a market opportunity. It makes you wonder, if something like grid fragility can be monetized, what other huge global vulnerabilities, from supply chain chaos to food shortages, are just sitting there, waiting for a similar shift in perspective?